Hey folks, so welcome back to another lesson, and this is now Speed of Sound Part 2. It's to look at solving problems using the speed of sound travelling through air, travelling through water, or when there is an echo effect. Okay, so we're going to use this idea of the speed of sound being different in different materials and also the echo effect. So just a wee reminder to you, speed of sound in the air is 340 meters per second, and speed of sound in water is 1,500 meters per second. And the other one, which is the speed of light, is 300 million meters per second. And remember, you always see it before you hear it. So let's have a look at some questions on speed of sound. So remember, we're going to use our good old friend speed distance over time, which I hope by now you are all experts at using. But just to remind you, here are the three equations you can have using this equation. You can copy this down if you want, but I'm hoping you are pretty good at this now, so you don't need to copy it down. And there's a wee bit extra when we're doing speed of sound. So for speed of sound calculations, you must bear the following. Speed of sound depends on the material it's traveling through. There may be an echo effect. This means that touch sound travels forwards, then backwards. So distance can be doubled or time is halved. So I would like you to write down these hints because we're going to be using these in the next couple of examples, and it's handy to have these in front of you to remind you how these work. So let's look at an example where we would do this from the experiment. So two pupils measure the speed of sound as shown. They are a distance of 250 meters apart. The time measured by the second pupil is 0.8 seconds. Calculate the speed of sound measured by the pupils. Now, if you're confident on how to do this, by all means go ahead and do it. If not, we're going to do it together. So let's look at the solutions. Remember our KFC technique, write down the information from what we've got. We've got distance and time, and then we write down an equation, plug in our numbers, and then calculate it. So we have an answer of 312.5 meters per second. If you want, you can round it to the nearest whole number. I'm just going to leave it to one decimal place in our answer here. Okay, hopefully you found worked example fairly straightforward. Let's look at worked example number 2 now. So the submarine uses sonar or ultrasound and picks up the echo 0.05 seconds later. Calculate the distance of the submarine from the island. So if you're confident, try it yourself. If you're not, let's look at this one together. So the thing you have to remember is that the sound has to travel forwards, then gets reflected back to the submarine. So you have to be very careful here because we're actually doubling the distance. Or in this case, we're halving the distance because we only want the distance from the submarine to the actual island. So we only want 1/2 of the distance that the sound has travelled. So how do we do that in terms of the calculations? Well, again, as we said, the echo has to travel forwards then back to the submarine. So we actually halve the time because we only want the time for it to go one way. And then the speed of sound in water is 1,500 meters per second. So notice how we're using two of our hints already. And then we're working at the distance. So distance is equal to speed times time, which is 1,500 times 0.025 seconds, which is an answer of 37.5 meters. So that is how far the submarine is from the island. Now, there is another way to do this. I'm not going to go into it. If you can think of the other way and you want to show it to me, that's great. But this is the way that I would want you to try these questions. Okay, let's try this one yourself now. A walker speaks into a loudspeaker and hears her echo 6 seconds later. Calculate how far away she is from the hill. So pause the video and try this one yourselves. Okay, so let's look at the solutions now. So hopefully you spotted that the echo has to travel forwards then back to the walker, but we only want the distance she is from the hill. So we do 6 divided by 2, which gives us 3 seconds. The second thing I hope you spotted is that we are now talking about the speed of sound in air and not water. So we're going to use 340 meters per second. We're then using the equation d is equal to v times t. So it's 340 times 3. So that gives us an answer of 1,020 meters. Now notice it's the same process as before. We figured out what it was we were trying to calculate and then worked out we had to halve the time. We then worked out which speed to use. Then we just used our equation and plugged in what we had and calculated the answer. Okay, final example. The fetus is 0.2 meters from the transducer. So this thing here, I'm going to circle it as the transducer, and that basically just gives it the ultrasound. And in this case, it says, how long did it take the ultrasound to be transmitted and received? And it gives you the hint, use the speed of sound in water, which is 1,500 meters per second. Again, if you feel confident, try this yourself. If you're not, we're going to do it together in the next slide. So the fetus is 0.2 meters from the transducer. How long did it take the ultrasound to be transmitted and received? So here, the echo has to travel forwards then back to the transducer. And because we want the total time, we have to double the distance. Because remember, the sound waves has to go out from the transducer, and then it's going to go back again to transducer. So here, we have to double the distance rather than halving it. We're using the speed of sound in water. And then we write down our equation, time is equal to distance over speed. So it's 0.4 over 1,500, which gives us a time of 2.6 times 10 to the minus 4 seconds. So notice it's really the same routine, but we have to think a little bit on our feet and realize that we're not halving it, but we're doubling it because of what we're being asked in the question. So you do have to think on your feet a little bit, but once you get through that, the rest of the question is just the same as before. We're working out whether it's going through air or water. We write down an equation, plug in our numbers, and then calculate it.